Welcome to my channel everybody and all the viewers who follow my channel. Here is the subject about partial differentiation and it is the base of syllabus for B.Sc and B.tech. Okay. Now, in case of partial derivative, so now we have to follow some formula of first principle for partial derivative. If it is written by x suffix x at x comma y, and that is equal to, we can write here limit h tends to 0 and see f of that is x plus h comma y minus f of x comma y by h. Okay, if it is differentiated by with respect to x and it is with respect to y, and at the point of xy, that is limit k tends to 0, then f of that is x comma k plus y minus f of x comma y by k. Okay, so this is the 2 point with respect to x, that is denoted by x suffix x, and also notation of this is del f del x actually, and this is actually denoted by del f del y. Okay, so this is the formula, and if we write here for x suffix x at a comma b, and that is equal to limit h tends to 0, so f of a plus h comma b minus f of a comma b by h, and f suffix y, and this is the partial derivative of y with respect to y, and that is at the point of a comma b, so that is here limit k tends to 0, so this is here f of a comma b plus k minus f of a comma b by k. Okay, so this is the formula for first order derivative with respect to x and with respect to y. In case of 0, if it is 0, so see at 0 comma 0, so this is the notation of limit h tends to 0 at a comma 0. In place of a, we can write here f of 0 plus h, so it is h comma and 0 minus f of 0 comma 0 by just put the value of a and b in place of that, then b, a and b are 0 0 and add 0 0. Okay, so in place of a we can put here a comma, in place of a comma we put here 0 comma 0, and that is here limit k tends to 0, and this is here f of 0 comma k minus f of 0 comma 0 by k. Okay, and for the partial derivative of higher order, now follow the partial derivative of higher order. Now for and this is the first order, and higher order means second order, up to second order. Okay, so if it is respect to x comma y, sorry, xy, not x comma y, this suffix xy, add a comma b. Okay, and this is denoted by with respect to x of the order of y here. So this is notation is that, so limit this is with respect to x, so that's why it is h tends to 0. So in place of function that is we denoted by f, see sorry, for that add a comma b, this is at a comma b, so add a comma b, in place of that we can write this formation, and suffix there is y, so f suffix y add, see the system xy with respect to x and with respect to s is this, so this is a plus h comma k minus x suffix y and comma a comma b by h. Okay, now find here f of y at a plus h comma k, and this is, see here, this is k, actually k tends to 0, we can write here, this is here k tends to 0. So in case of k tends to 0, this is here k tends to 0, add a comma b, so see, add a comma b, in place of a comma a, here is a plus h here, so we put here a plus h, so f of a plus h, and in this is here k, and this is here comma b, and b not k. Okay, so this is here b, so see a comma b, so a in place of a, in place of b here is b plus k, in place of a is a plus h, in place of a plus h is a plus h, in place of b that is b plus k, and minus f of a plus h comma b by k, actually is this. Okay, so now this is the first order derivative, and this is the higher order, and this is the notation of that. Now obtain, question number 1, obtain f suffix x at the point 2 comma 3 and f suffix y at the point 2 comma 3, and with respect to x is this. So this is here, and follow the rules here. Okay, follow the rules here with the help of first principle. So this is here limit h tends to 0, so c that is f of 2 plus h comma 3 minus f of 2 comma 3, well, this is 2 comma 3 by h. Now function is f of x comma y is x plus twice y minus 3 by twice x plus y plus 3. So put here find the value of that. This is 2 plus h minus 3 comma 3, and in place of x we put here 2 plus h, so we put here 2 plus h plus y is 3, this is 3 minus 3, in place of x this is 2 plus h, in place of y this is 3 plus 3, and that is h plus 6 plus 8 minus 3, this is 5, and this is twice h plus 2 to the 4, and 4 6 is 10. Okay, so h plus 5, take a common 2, this is h plus 5, this is their half, and now find f of 2 comma 3. So this is here 2 comma 3, In place of x we put here 2, in place of y we put here 3, minus 3 by 2 to the 4 plus 3, and this also plus 3. So 6 plus 2 8 minus 3, this is 5 here, and also this is a 10, so this is a half. So therefore the f suffix x at 2 comma 3, and this is your limit h tends to 0, and the value of that is half minus half by h, and this is 0. Okay. In case of y, so now find f of y at 2 comma 3, and this is the limit k tends to 0, and this is f of 2 comma 3 plus k minus f of 2 comma 3 by k. Now find out this function 2 comma 3 plus k, and that is equal to, in place of x we put here 2, okay, in place of y we put here 3 plus k minus 3, same as in place of 2 to the 4 here, and in place of y that is 3 plus k and plus 3 here. So this is equal to twice times of k, and that is 6 plus 2 8 minus 3, this is 5 here, and also see here that is k plus 6, this is 10 here, okay. Six 8 minus 5, okay, and this is here k plus is this, okay. Now f of, actually it is already found, this is 2 comma 3 is here half, okay, so now we need to find here. So therefore x suffix y 2 comma 3 is k tends to 0, and the function is this 2k plus 5 by k plus 10 this is 2 comma 3, f of that is half by k, this is k tends to 0, then we take LCM here, 2 into k and k plus 10, so see this is 4k plus 10, this is minus k minus 10, okay. So this is 3k here, limit k tends to 0, this is 3k by 2k and k plus 10, this k are cancelled, so k tends to 0, k never be 0, so this is 3 by 2 into, this is 10 here, okay, so this is 3 by 20, okay. So this is the question number 1 solution, see carefully, okay. Now we proceed to the second question, okay. Second question is that find from definition and without definition. We follow the without definition first. P equal to x square plus xy plus y square, and find the derivative of p with respect to x partially. So when differentiate p with respect to x, then x is variable, then other is constant. So in that case, so y is a constant. So differentiate x with respect to x square with respect to x is twice x, and with respect to x then y is a constant, then got here y, and the derivative of y square is 0. Same as partial derivative of p with respect to y, so derivative of x square is 0. So with respect to y, y is variable, so differentiate y is 1 and x is left here, and the y square is twice y. Okay, this is the without using the first principle. So we got this. Okay, if we follow the first principle here, so the this is we can write here f of that is x comma y here. Okay, and simply just follow the question number 1. Just I have followed the question number 1. So that type of solution is that. Now dp dx letter f, okay, so this is your limit h tends to 0. So now we can write here that is x plus h minus comma y, and this is f of x comma y here yk. Sorry, this is your h. So limit h tends to 0. So from that f of we need to find the value of x plus h comma y here, and in place of xy, say then this is the function. Now we want to find the x plus h comma y. So in place of x we put here x plus h. Okay, so this is whole square. In place of x we put here x plus h here into y and plus y square. Now simplify x square twice xh and xh. Okay, and this is h square plus xy plus hy plus y square. Now the value of this is, okay, in place of that put here x square 2xh plus h square plus xy, this is hx plus xy x square y square, and xy is that minus x square minus xy minus y square by h. So from that I cancel this, okay, and xy and xy also cancel. So this is, for the next step here is we can take a common h. Then we have left here twice x plus h plus y, and by h, since h tends to 0, h not equal to 0. So now put here twice x plus y. See, this is the answer. Tally with that. Okay, similarly we can find del p by del y. Okay, and this is and same procedure. Okay, with the help of the first principle of with respect to y is there. Okay, now next question is third. 3. Very interesting question. See carefully. And most of the examination for B.Sc and B.tech, this type of question always given. And 3 and 4 is very interesting question. So see carefully. Now you have given 3 f of x comma y, and that is twice xy by x square plus y square, where x square plus y square never be 0, and this is equal to 0 when x square plus y square equal to 0. And see in that case separately can write here x equal to 0 and y equal to 0 also. So now we have to find the value of this is x suffix 0 comma 0. Okay, so see, so f suffix x with respect to x at the point 0 comma 0. So see, with respect to a comma b is this, and with respect to 0 comma 0 we can write here limit x tends to 0. This is f of h comma 0 minus f of 0 comma 0 by h. Okay, and now in place of h comma, now f of x comma y is twice xy by x square plus y square. Okay, so from that f of h comma 0, so this is 2h into y is 0 here, so x square means this is h square plus y is 0 here. Okay, so you can simply write here 0. So add 0. So add 0 means, therefore we can write our x equal to y equal to 0. So at 0 comma 0 is that. Okay. Therefore, f of x at 0 comma 0, limit h tends to 0. So this is at h comma 0. So the value of h comma 0 here is 0. And the at 0 0 is 0 by h. And this is equal to 0. Okay. Sorry. And this is, now we have to find if a derivative of y with respect to y, derivative of f with respect to y, and at 0 0 is a limit that is k tends to 0. Okay, f of 0 comma k minus f of 0 comma 0 by k. Okay, see the calculation here, same as f of 0 comma k. So you put here 0 comma k, then 0 by 0 plus k square. So this is here 0, and f of 0 comma 0 is 0. So therefore limit k tends to 0, this value is 0 by 0 minus 0 by k, and this is equal to 0. So both the value are exist. Okay, both the differentiation with respect to x and respect to y are exist. Okay, from the first principle. Okay, see carefully. This is the interesting question. Now we have to proceed to the question number 4 here. So now this is your queries. Question number 4. F of x comma y is that xy x square minus y square by x square plus y square, when x square plus y square never be 0, and equal to 0 when x square plus y square equal to 0. Actually, since x equal to 0 and y equal to 0. Okay, when this is there. Okay, now we have to follow the second order. So d2f dx dy. Okay, this is the notation of the second order with respect to first y, then after y, then after x. So this is here h tends to 0. So f suffix y at C, in case of with respect to x, is limit h tends to 0, f of x plus h comma y minus f of x comma y by h here, and this is with respect to y. See, this is the partial derivative of y, so that's why notation is f suffix y. Now therefore del 2f del x del y at 0 comma 0, and that is equal to limit x tends to 0. This is f of h comma 0 minus f of y and y 0 comma 0 by h. Okay, so now h suffix y at h comma 0. This is equal to limit k tends to 0, f of this is y a comma b, this is h comma b plus k, that is 0 plus k, minus f of h comma 0 by h. See, this is limit k tends to 0, so h comma k, that is h comma k, so h k h square minus k square by h square plus k square, add h comma 0. So add h comma 0, then whole thing is 0, so that is a by h. So this is equal to h and h cancel since h tends to 0. Okay, so now put the value of k is 0, h square minus 0 by 0 plus h square. Okay, so h square cancel, and this is equal to 1 here. Oh, this is your k. K are cancelled. Okay, so that is h into h square minus 0 by h square plus 0, and that is equal to h. Okay, now we have to find y at 0 comma 0. So this is at y comma 0. This is limit k tends to 0 here, and this is the f of 0 comma 0 plus k comma k minus f of 0 comma 0 by k. Okay, so 0 comma k, so 0 comma k is 0 minus 0 by k. So this is equal to 0. So and 0 comma 0 is 0 here. Therefore we have, therefore this is 0 comma 0 is equal to the value of, this is your limit h tends to 0, h comma 0, and this is value h here, and we can use 0 here by h, and this is equal to 1. Del 2f del y del x, that is equal to this is equal to limit k tends to 0. So x suffix x, that is here 0 comma k minus 0 comma 0 by k. Okay, see, now find 0 comma k. So this is equal to limit h tends to 0. So with respect to x at a comma b, so a comma b, a is 0, so 0 plus h comma k minus f of 0 comma k by k. Okay, now we have to find the value of that. H comma k, so h comma k, and this is equal to h comma k. We put that h k h square minus k square by h square plus k square. Okay, and 0 comma k, 0 k 0 0, whole thing is 0 by k, and this is here limit k tends to 0, okay, k or k cancel. So this is equal to, if we put the value of k, put the value of h equal to, sorry, this is h tends to 0, put the value of h equal to 0, 0 into 0 minus k square by k square, then whole thing is 0 here. Okay. Now x suffix 0 comma 0, limit h tends to 0. So this is here h comma 0 minus f of 0 comma 0 by h. H comma 0, whole thing is 0. 0 comma 0 is 0 by h is 0. Therefore, del y del x at 0, and that is equal to limit k tends to 0, and this value is here what, minus k. This value is 0 by k, and this is minus 1. Therefore, del 2f del y del x not equal to del 2f del x del y at 0 comma 0. Okay, proved. Now we have to proceed to the next question. See careful, okay, very interesting question. This is a very important question, okay? So take care, okay? And follow the first of all we write these, fine, then we easily proceed to the problem. Actually sometime write on the left hand side, then we follow the formulas, okay? Then it will be helpful to all of you, okay? So see, somewhere our mistake or somewhere we see the respect to y, this is k tends to 0, I wrongly written that h tends to 0, that's why there is some problem, okay? So see carefully, okay? Now follow the question number 5. U is equal to log of xq yq zq minus 3xyz. Okay, now xq yq zq minus xyz, and the factor be x plus y plus z, and the other factor we have x square plus y square plus z square minus xy minus yz minus zx. Okay, and from that x plus y plus z, and we can easily factorize this as a x plus y omega plus y omega square, and also x plus y omega square plus this is your z omega. Okay, see the calculation here. Now this is your log, so therefore E is equal to log of that, so a product, so we can write as the addition x plus y plus z plus log of x plus y omega plus z omega square, so log of x plus y omega square z omega. Okay, now differentiate del u del x. So that is x plus y plus z, that is by x plus y omega plus z omega square, that is 1 by x plus y plus omega square plus z omega. Okay, 1 by that and differentiate with respect to x, then 1, and this is 0, same as 1 by that. We got here as respect to x is 1, another thing is 0, same as this. So we got here on that there is a 1 only. In case of respect to y, so 0 0 y is omega here, so this is here omega square. Similarly, with respect to z, so z square is omega square, so adding these 3, so we got the 1. Okay, we got 1. So this is 3y x plus y plus z, and this is the LCM of these 3, all are same, so we got a on the numerator part be 1 omega square, so that is LCM be x y omega and z omega square, same as y plus omega square plus omega, and this is your x y omega square plus z omega. See, cube of unity we know 1 plus omega square be 0 here, so these two things is 0 here, so 3 by, so we can write here only this is only 3 by x plus y plus z here. Okay, so this is the first root. Okay, now proceed to the second. And for that, so dtu dx2, so you got here minus only. Okay, same as differentiate this, minus 1 by okay, same as 1 by okay, so minus 1 by this is omega because omega square, so this is omega to the 4, so this is omega to the 4 to again differentiate this, then we can have omega to the 4. Again this is minus, if we differentiate this with respect to z, then we got this, and also with respect to z, omega square, omega to the 4 here, so we have left here 1 plus y omega and z omega square and whole square, and if we differentiate this, we got here omega square and over x plus y omega square and z omega whole square. Okay, now I added these 3, so added these 3, then we got this is 3y minus 3y x plus y plus z whole square actually, and this sum also a 0. 1 plus omega square plus omega to the power 4. Omega to the power 4 means omega. So sum of the value of this 3 is 0. Okay, same as this. So we got the last answer. Okay. Now let's proceed to the second. For that, we want to write only this is the second. Okay, now for third, we use only 1. Okay, so this is here. This is here u, so you can written like that. Okay, so this is here. Okay, see the value of that is this is here 3 by x plus y plus z. So differentiate this with respect to this, there is 3 by minus actually x plus y plus z whole square. Okay, same as with respect to y is got here minus 3 by x plus y plus z whole square, and differentiate this with respect to z, you also have 3 by x plus y plus z whole square. Okay, so 3 this is minus 9 by here x plus y plus z whole square. Okay, bye everybody. This is the interesting class today, and follow the video carefully. Okay, bye everybody.